The Foundations of Geometry by David Hilbert.
Chapter 6, Pascal's Theorem. Section 31, two theorems concerning the possibility of proving Pascal's theorem. As is well known, Desargues' theorem, Theorem 32, may be demonstrated by the aid of axioms groups 1, 2, and 3. That is to say, by the use, essentially, of the axioms of space. In section 23, we have shown that the demonstration of this theorem without the aid of the space axioms of group 1 and without the axioms of congruence, group 4, is impossible, even if we make use of the axiom of Archimedes. Upon the basis of axioms group 1, 1 and 2, groups 2, 3, and 4, and hence by the exclusion of the axioms of space, but with the assistance, essentially, of the axioms of congruence, we have, in section 14, deduced Pascal's theorem and consequently, according to section 22, also Desargues' theorem. The question arises as to whether Pascal's theorem can be demonstrated without the assistance of the axioms of congruence. Our investigation will show that in this respect, Pascal's theorem is very different from Desargues' theorem. For in the demonstration of Pascal's theorem, the admission or exclusion of the axiom of Archimedes is of decided influence. We may combine the essential results of our investigation in the two following theorems. Theorem 36. Pascal's theorem, Theorem 21, may be demonstrated by means of the axioms of groups 1, 2, 3, and 5. That is to say, without the assistance of the axioms of congruence and with the aid of the axiom of Archimedes. Theorem 37. Pascal's theorem, Theorem 21, cannot be demonstrated by means of the axioms of groups 1, 2, and 3 alone. That is to say, by exclusion of the axioms of congruence and also the axiom of Archimedes. In the statement of these two theorems, we may, by virtue of the general theorem 35, replace the space axioms of group 1, 3 through 7, by the plain condition that Desargues' theorem, Theorem 32, shall be valid.
The Foundations of Geometry by David Hilbert. The material contained in the following translation was given in substance by Professor Hilbert as a course of lectures on Euclidean geometry at the University of Göttingen during the winter semester of 1898 and 1899. It was translated by E. J. Townsend, Ph.D., University of Illinois. The text was downloaded from Project Gutenberg with the following notice. This ebook is for the use of anyone, anywhere in the United States and most other parts of the world at no cost and with almost no restrictions whatsoever. Read by Jim Renholt. Programming and illustrations by Jim Renholt. 2019. Portrait of David Hilbert by Rita Ray Renholt. Thank you for listening.